So now, in previous videos, we looked at how you can give an input voltage to a PNP bipolar junction transistor wired as an emitter follower. You can see we got a resistor on the emitter side right there. That means at the emitter, you're going to get that base voltage, but it's going to be 0.6 volts higher, but it will follow the voltage. And of course, you got limits. But in any case, that could be a problem. You don't want that 0.6 volts higher. There's also the NPN bipolar junction transistor emitter follower. The voltage that you give at the base will be transferred to the emitter, but you're going to lose about 0.6 volts. Right there, it's going to be about 0.6 volts lower. And then again, you got some limits, but for the most part, it's going to follow that voltage across the whole range if you had the trim pot over there. So what we can do, if you want the input voltage and output voltage to be pretty much exactly the same, it may, differ just slightly, but it's going to be well within 1/10 of a volt. It should be. So in any case, what you can just do is cascade a PNP bipolar junction transistor, which will raise it about 0.6, maybe 0.7, and then an NPN, which will drop it about 0.6, maybe 0.7, and therefore, whatever voltage you put in will be the voltage that will come out. So to start with the build, we're going to use a trim pot. So that's a symbol for a potentiometer. You put the voltage across the resistive element, and there's the wiper. So the two end terminals are the ends of the resistive element, and then the middle pin is the wiper. I like to put these little dashes where I have my two supply rail pins right there, and to snap her into place, I'm off a spot right there. So I was looking through the camera when I stuck it in there, and so kind of slides it off, but yeah, it should line up like that. And now we'll insert our PNP bipolar junction transistor. This says 2N3906 on it, and I know the pin layout: emitter, base, collector. You can see the emitters on top, so I'm going to swivel it that way. Now it's on top there, and I have a jumper to ground for the collector right there. And current doesn't go positive negative that way, so we can go directly to ground, even if we turn the trim pot all the way to the positive supply. The trouble that we could run into is working positive towards negative like that, and we're going to solve that problem with a 10K resistor right there, pull-up resistor, going to the emitter of the PNP bipolar junction transistor. I'm using a 2N3906. And then we got a jumper headed that way to the NPN transistor. So now I got a 2N3904. And again, pin layout is emitter, base, collector, but the emitter goes to the other supply voltage. And so we're going to put the collector there to the positive supply. That's the top pin. The base is going to the jumper that is going to the PNP emitter, and also the pull-up resistor, the 10K resistor. And now we're going to add a 10K resistor to help make sure that whatever voltage we get there, it's 0.6 volts lower there, because some loads may confuse it. So that's going to be the 10K resistor, this one up here, and we're going to put it to ground. Now there's no power right now. We'd have to measure this with a voltmeter to see the voltages once I apply power, but instead I'm going to take an LED, make sure you put it in the right way, and I'm looking through the camera, so my aim was off a little bit. There you go. And I'm going to protect that with a 220 ohm resistor, because we're working with 5 volts. So we have a visual load here. I'm going to turn the power on, but the trim pot is to the bottom anyways, so it wasn't going to turn on. Had to find my screwdriver there. And now I'm going to turn it. There you can see it lights up. And we're not going to get the full 5 volts because we're using an NPN bipolar junction transistor. But as long as we stay above about 4.4 or 4.4 volts or lower, I should say, the voltage should be following along with what we set at the trim pot. So now we're actually going to measure the voltages. Got a multimeter there. This is auto ranging. All I have to do is set it to V. It does the rest as long as we're measuring DC there. And don't have to move the red probe for anything but high current. Other meters, you may have to move the red probe, maybe even the black probe, for different readings. So I'm going to, instead of holding the probes to stuff, which also will kind of give us a false reading because this is a cheap board. They don't make great connections. So we'll get better connections if I just put this jumper in somewhere instead of pushing components with the probe. And now the red one, this is going to be the voltage in relationship to 0 volt ground right there. So the output of the trim pot comes to the base of the PNP bipolar junction transistor. They have the same voltage. So 24 or 2.48 basically right there. And now, so let's just say 2.5. That should be close enough. Now we're going to come up to the emitter. It's going to be about 0.6 volts, maybe 0.7 volts higher. So we should be above 3 volts right there, just a little bit though. And you can see that. Now that comes to the emitter of the base, I mean, of the NPN bipolar junction transistor. Emitter is going to drop it back down approximately 0.6 volts, not perfectly, less than what we got there. So we're going to get back below, maybe a little bit below 2.5 volts as we saw there. So it's not following perfectly, but it's pretty close. 2.42 versus our input 2.49. So much better though than that extra voltage we're getting from the PNP or a voltage drop from the NPN. They are canceling each other out. Now we will look at the that's the trim pot voltage. Of course, the trim pot voltage can go the full range of the supply, up to 5 volts down to 0 volts. And we will look at the output of the NPN. And we got that base to emitter drop, so we can go down to 0 volts. And looks like didn't quite make as close to 0 as a trim pot, but still pretty close to 0. And it should be about 0.6 volts, maybe 0.7 volts less than the positive supply. Looks like we got a whole volt down there, so I didn't think it would do that bad. But yeah, definitely expect that you're not going to get the full range of the supply if you do this. Stay in more of a middle ground region for the most part. You know, 4 volts is like still okay in this case, but just be aware that if we didn't have a load, maybe it'd be a little different as well. But that's just something to be aware of. We got rid of the offset, the going up for the PNP and the going down for the NPN. Not the best way to make this circuit, but if you got transistors laying around, it's a really simple way right there to get practically the same voltage out that you're putting in, because this is just a signal.